What was the significance of Osborne Reynolds's fluid flow experiments? Imagine watching a simple stream of water and seeing it change from smooth to chaotic without any warning. That's exactly what Osborne Reynolds observed in his experiments. His work in the late 1800s changed how engineers understand how fluids move. When he injected dye into flowing water inside a glass pipe, he saw two very different flow patterns. One was smooth and orderly, with layers of water sliding past each other. The other was chaotic and mixed up, with irregular swirls and eddies. These are called laminar flow and turbulent flow. Reynolds found that the switch between these two types of flow depended on a special number called the Reynolds number. This number combines flow speed, pipe size, fluid density, and viscosity into one simple value. It tells engineers whether the flow will stay smooth or turn turbulent under certain conditions. This discovery is a big deal because it helps predict how fluids behave in pipes, airplanes, heat exchangers, and many other systems. Reynolds' experiments also created a way to classify flow regimes, which is important for designing efficient systems. Knowing if the flow is laminar or turbulent affects calculations for pressure loss, heat transfer, and forces on structures. His work laid the foundation for studying flow stability and how transitions happen from smooth to chaotic flow. It also influenced the development of modern computational tools that simulate fluid behavior. Reynolds' findings are still used today in designing piping systems, pumps, turbines, and even aircraft wings. His experiments gave us a clear picture of how fluids change behavior and introduced a key number that guides engineers in making smarter, safer designs. Without his work, understanding fluid flow would be much more complicated, and many modern engineering systems wouldn't work as efficiently.